Today, we're going to crack open Python's data toolbox. We're talking about the absolute fundamentals, how programs make sense of information. What is programming really about? It's about bringing order to chaos. I mean, how do you take all this messy, real-world info, a jumble of numbers, names, all these facts, and whip it into shape so a computer can actually understand it? Well, it all comes down to using the right tool for the right job. Python's main data structures, lists, tuples, dictionaries, and sets, they're like your own personal toolbox. Each one is designed for a very specific task. Some are like flexible bags you can throw anything into. Others are more like solid, unchangeable containers. Knowing which tool to grab is the secret to writing really clean, really efficient code. Okay, first things first. Let's get all of our tools out on the workbench. It's time to see what makes each one of these tick. Okay, you're going to want to bookmark this slide in your mind. This is basically your cheat sheet. It really boils down our 4 data structures to 2 make-or-break questions. First, is the order of the items important? And second, can you change the items once you've made the collection? So you can see, lists and tuples, they're ordered. Sets? Nope, totally unordered. And dictionaries? Well, they're a little special. They used to be unordered, but now in modern Python, they actually remember the order you put things in. That's a super handy detail to keep in your back pocket. If Python's toolbox had a Swiss Army knife, the list would be it. It's versatile, it's powerful, and honestly, it's probably the first thing you're going to reach for 90% of the time. So what exactly is a list? Well, it's an ordered collection. That means things stay in the exact order you put them in. And it's mutable. Now, that's just a fancy programmer word for changeable. You can add things, you can remove things, you can swap things out whenever you want. And just look at the example here. You can mix and match. We've got a number, some text, a decimal, a true-false value, all in one list. Now that is flexibility. And here's that mutability thing in action. Let's say we start with this list of data. 10, 20, 30. We can use .append to tack a 40 right onto the end. Easy. Then, maybe we want to get rid of the 20. No problem. .remove 20 takes care of that. And .pop? That just yanks the very last item off the list. See? It's like a living, breathing container for your data. Okay, you ready for a real pro tip? This is called a list comprehension. I know it looks a little intense at first glance, but I promise it's one of the most powerful and, honestly, beautiful ways to create lists in Python. In just one single line of code, what we're saying is this: hey Python, make me a new list called evens. Go through all the numbers from 0 to 9 and give me back every number x, but only if it's an even number. And bam, you get the result. Let's just break that down real quick, because it's actually a simple recipe. There are 3 parts. First, the expression. What do you want to do with each item? Here, we just want the number x itself. Second, the iteration. What's the loop? That's our for x in range 10. And third, the optional part, the condition. What's the filter? For us, it's if x%2 equals 0. That's it. Expression, iteration, condition. Once you get that pattern down, you'll use it everywhere. Okay, next tool out of the box is the tuple. And if a list is like a flexible, adjustable wrench, then a tuple is like a solid, forged, single-piece tool. It's built for one thing: stability. What's funny about a tuple is that it's kind of defined by what it can't do. Just like a list, it's ordered. But the big, huge difference is that it's immutable, unchangeable. Once you create a tuple, that's it. It's set in stone. You can't add to it, you can't take away from it. It's like a snapshot in time. This is perfect for data that should never, ever change. Think about stuff like GPS coordinates or maybe a person's date of birth. Now, one of my favorite things about tuples is this super elegant trick called unpacking. Just look at this. We have a tuple with 1, 2, and 3. And in one clean, beautiful line, we can assign each of those values to a separate variable. So A becomes 1, B becomes 2, C becomes 3. It's so clean and so readable, you'll find yourself looking for excuses to use it. So when it comes down to choosing between a list and a tuple, it's actually a pretty simple choice. It's all about that one word: mutability. If you need a collection that's going to grow or shrink or change in any way, you want a list. But if you have data that needs to stay locked down and constant, you reach for a tuple. Making the right choice here really makes your code safer and just clearer for anyone else who reads it. Now we're going to talk about dictionaries and sets. These are highly specialized tools, and they're built for 2 things: raw speed and enforcing uniqueness. Order isn't really their main job. So let's talk about dictionaries. They store information in what we call key-value pairs. So instead of grabbing an item by its position, like the first item or the third item, you grab it using a unique key. Look at this person dictionary. The key is name, and the value it points to is Alice. It works exactly like a real-world dictionary. You look up a word, that's the key, to find its definition. That's the value. And the reason we do this, it makes looking things up incredibly fast. And then we have sets. Sets live by one simple but super powerful rule. Everything inside a set must be unique. You can't have duplicates. If you try to add an item that's already in there, Python just ignores you. It does nothing. This makes sets the absolute perfect tool for stuff like, say, getting all the duplicates out of a list, or just checking really quickly if an item exists in a collection. But this is where sets really show off. They can perform these high-speed mathematical operations. For example, a union, use that little pipe symbol, it just mashes two sets together, and it automatically gets rid of any duplicates, like the number 3 here. Or an intersection with the ampersand, that gives you only the stuff that's in both sets. It's such a powerful and fast way to compare two groups of things. Okay, so we've got our containers, right? Our lists, tuples, dictionaries, and sets. But what are we actually putting inside them? Well, a lot of the time, it's going to be text. And let's be honest, text data in the real world is almost never clean and perfect. It's messy. And that's where string manipulation becomes an essential skill. So let's look at a few of the most common cleanup jobs. Say you've got this messy string with all this extra space around it. You can use .upper to make the whole thing uppercase, or .strip to just shave off that leading and trailing white space. Need to swap a word out? .replace has got you covered. Seriously, these 3 methods are the absolute workhorses of data cleaning. And you have to know this next combo. It's a fundamental 2-step process. First, you take a single string, maybe something you've read from a file, and you use .split to break it into pieces. Here we're splitting on the comma, which gives us a nice list of items. Then you can take that list and join it back together into a new string, maybe with a totally different separator. This split and join dance is how you fundamentally restructure text. And last but definitely not least, we have to talk about f-strings. If you're building strings that need to include variables, this is the way to do it. It's modern, it's super readable, and it's fast. All you do is put a little f right before the first quote. Then you can drop your variables right inside the string just by wrapping them in curly braces. It is so simple, so clean, it's just awesome. We have covered a ton of ground. So before we wrap up, let's do a quick recap of the essential tools we've just added to our programming toolbox. So let's really lock these ideas in. Here are the key takeaways. Remember, it's all about using the right tool for the job. You want flexibility? Grab a list. You need your data to be constant and safe? Use a tuple. Need super fast lookups by a key? That's a dictionary. And if you need to guarantee everything is unique, you want a set. And holding it all together is string manipulation. That's the skill that lets you whip your messy text into shape in the first place. You now have the fundamental building blocks to organize pretty much any kind of data you can imagine.